So our lesson on sound now is going to take a slight shift in our concentration. The first 5 lessons really looked at applications of sound and sound as it pertained to, say, individual waves. And for the rest of the unit, we're going to look at what happens when 2 or more waves interact with each other. Okay. This lesson, lesson number 6, is about the principle of superposition, which is really devoted. It's really something. It's a mathematical principle that's seen in a lot of different areas of physics. The interaction between waves is called interference. Okay, so when 2 waves interact at the same point in space and time, they interfere. And the principle of superposition basically tells us that when 2 waves interfere with each other, the net wave that forms, basically at the point of interference, has an amplitude that's equal to the vector sum of all the wave amplitudes that come together at that point. So the principle of superposition applies in all different areas of physics. And in fact, when we took net force in our forces unit and we looked at what F net was equal to, we were saying, hey, at this point in space and at this point in time, these forces are acting on this object. And we took a vector sum of those forces. And we said, oh, they're going to add together to give some overall net force. Really, we were doing the principle of superposition with forces. Well, now we're going to do the principle of superposition with waves. And basically what we say is let's say we have 2 pulses. Here's pulse A, and here's pulse B. Okay? And let's say there's one string that's kind of attached this whole distance right here, and pulse A moves down the string this way, and pulse B moves down the string this way. When those 2 waves meet each other here in this region, and at this point in space and time, they will result in a pulse that equals the addition of their amplitudes. So here we've got, at its peak, we've got an amplitude of 3, and here at this wave's peak we have an amplitude of 1, and so the amplitude of the resulting pulse right in the middle would be 4. And that's a very simple example. A couple of terms that come out of this is that the resulting wave, which we call the resultant, is the amplitude of the 2 original waves. So here, constructive interference happens when 2 waves basically build up or increase the wave's amplitude, and we call that constructive interference. Destructive interference, on the other hand, is when 2 waves meet and they tear down or they decrease the wave's amplitude. Okay. Superposition, the principle of superposition, is a very general but very useful concept in physics. It has applications in all kinds of different areas, and we talked about certainly Newton's laws, but it also has applications in electromagnetism and sound and, of course, light. It has all these applications, and it's a very, very general, but we see it all over the place. And we'll come back to it in different areas of grade 11 and grade 12 and really get a good sense of what it's all about by the end of high school. Here's example 1. Use the principle of superposition to draw the resultant wave that would be visible given the pulses A and B. So just like the first kind of conceptual example, here's 2 pulses. These are square pulses. Here's pulse A and here's pulse B. And so our general method for drawing these 2 pulses is to basically add their amplitudes. So here we've got 0 amplitude, here we've got 0 amplitude, so the resultant is 0 plus 0. Here we've got 0 during this section, and we've got 0 during this section, so the amplitude is, of course, 0 again. But here at this pulse, now it jumps to an amplitude of 4. And here we've still got 0, so 4 plus 0 is, of course, 4. And that continues right until we get to this point here, when this amplitude jumps to 2, and this amplitude is still at 4, so we would get an amplitude of 6. And so our resultant pulse looks just like this, where when they're exactly over top of each other, they add together to create this. Let's take a look at a different example with a couple of pulses here, pulse A and pulse B. And of course, the resultant pulse is right here, drawn out for us. And so let's take a look then. Let's just check and make sure that this is in fact correct. Here at this point, 2 units in, we've got an amplitude of 0 and an amplitude of 0. And of course, here we have an amplitude of 0. At the peak, this wave has an amplitude of 5 units. This wave has an amplitude of -2 units. So 5 minus 2 is, of course, 3 units. And that's what we see here, is we see an amplitude of 3 units. Of course, this then continues down so that we get back here to an amplitude of 0 and an amplitude of 0, and the pulse continues itself out. So the important thing with this kind of an example is that there might be a few crucial points that you can pick along the pulse to really make your construction of these resultant pulses a little bit easier. There's a lot of examples in your textbook that you can try. Some of them are quite challenging, so take your time and make sure that you're adding the amplitudes very carefully, very slowly. Good tip is to definitely use a little bit of graph paper for these questions. It seems to make them much easier. Sound waves and matter. We know that waves can either be absorbed, transmitted, or reflected when they encounter different types of matter. And so this example, or this topic, is left as a reading assignment for students. Take a look at your textbook and describe absorption, transmission, and reflection by summarizing what your textbook has to say. Please make special attention of any equations that the textbook gives. You may want to put them in boxes so that we can discuss them, because we are especially going to come back to reflection in the next couple of days. But we do want to talk about absorption and transmission and what happens in these cases. All of this very important, so this is left as a reading assignment. In class, of course, we'll do this right after the lesson. But if you're watching this video, this is something that you're going to want to do probably now. Crack open that textbook and take a look for absorption, transmission, and reflection.